Everybody, in this video we're going to talk about how to find the volume of a cone. So when we think about the volume of a cone and its formula, it compares closely to the volume of a cylinder. So we've done a previous video on how to find the volume of a cylinder, and I'll link that in the cards right now. On the left side of our screen, we see that the volume equation for a cylinder is pi r squared times height. Well, if we look over here at the right, we see in this navy box that a cone that has the same radius and height as a cylinder will have 1/3 the volume of the cylinder. So that will give us our volume equation for a cone just being volume equals 1/3 pi r squared times height. So this is our equation that we're going to use in this video when we find the volume of a cone. So we're going to look at 3 examples here and then a couple more after these 3 where we find the volume, and then we're going to use the volume to find the height and the radius. So for number 1, we want to find the volume. So volume is equal to 1/3 pi r squared times height. We have our radius here is 10, so volume equals 1/3 pi times 10 squared, and our height would be 8.4. So now we can just plug this information in, and essentially we can do 10 squared, which is 100, and we can multiply that by 8.4, and we can divide that or multiply by 1/3. So now we have 280 pi meters cubed, and we can write our volume in terms of pi, like 280 pi, or we can multiply 280 times pi to get our volume as a decimal approximation, so 879.65 cubic meters. So that would be our volume for number 1. Okay, for number 2, we are given the volume. The volume is 96 pi meters cubed. We are also given the radius 6 meters, and we want to find the height. So we can use our volume equation, but now we just want to leave h, and we want to find what h is. So now we have volume equals 1/3 pi r squared times the height. Our volume is 96 pi equals 1/3 pi. Our radius is 6 times the height. So this gives us 96 pi equals 6 squared is 36. 36 divided by 3, or 36 times 1/3 would be 12. So we have 12h, we have 12 pi h, and now we can divide both sides by 12 pi to figure out what h would be. So now the pi's are going to cancel, and we can do 96 divided by 12, and that gives us a height of 8 meters. All right, and number 3, we want to find the radius of the cone. So we're going to use our volume formula again. We have our volume at the top, so we're going to say volume is equal to 1/3 pi r squared times height, and we're going to plug in our given information. So our volume is 245 pi, and that's going to be equal to 1/3 pi times the radius squared times 15. So now when we multiply together on the right side, we get 245 pi is equal to 15 times 1/3 would be 5. So we have 5 pi r squared. So we're going to divide both sides by 5 pi here. So once again, those pi's are going to cancel, so 245 divided by 5 gives us 49. So we have 49 is equal to r squared, and we can now take the square root of both sides to figure out what r would be. And so we get a radius of 7 inches because the square root of 49 is 7. Okay? All right, now let's do 2 more examples that maybe ask us to do something a little bit different. So for number 4, we want to find the volume. But if you notice, we are given the radius and we are given the slant height. We are not given the actual height of the cone, so we need to find that so that we can use that measure in our equation. Okay, so we know that our equation is volume equals 1/3 pi r squared times height. So currently we have 1/3 pi, we have 5 squared, but we don't know what our height is. So to find that, since we have a right triangle here, we can use a Pythagorean theorem. So we have 5 squared plus b squared, so I'm going to let this be b for right now, is equal to 8 squared. So 25 plus b squared equals 64, and we subtract 25 from both sides. So now we get b squared is equal to 64 minus 25 would be 39, and now we take the square root. So we're just going to say that b is equal to the square root of 39. Okay, we're going to leave it as 39 because that's not a perfect square, and we don't want to approximate it right now. So we're just going to say that this height is the square root of 39, and it would be feet. Okay, so now we're going to plug that in right here, square root of 39. Okay, so now we're going to multiply. So 1/3 pi, this would be times 25, and then times the square root of 39. So now I'm going to do 25 times the square root of 39. And then we're going to divide that by 3, or, like we said, multiply it by 1/3. So now volume is equal to 52.04 pi cubic feet. And if we want to multiply this by pi, then we would get our decimal approximation, which would be 163.49 cubic feet. So these would be our two answers for the volume for number 4. And lastly, for number 5, we have a composite solid. If you notice, we have a cylinder at the bottom and we have a cone on top of the cylinder. So to find the volume of the composite solid, we're going to find the volume of each shape and we're going to add them together. So in this case, we have our cylinder, which would be pi r squared times height. So we'll call this the cylinder over here. So we have pi, our radius is 3, and our height is 10. So this gives us 3 squared is 9, 9 times 10 is 90. So 90 pi meters cubed. So we'll put a star by that because that's part of our volume. And then for the cone, we're going to take volume is equal to 1/3 pi r squared times height. And we can go ahead and plug those numbers in and we're going to see kind of what's going to happen here. So 1/3 pi, our radius is still 3, but now the height of our cone is 5. So we get volume is equal to, this would be 3 squared, which is 9, 9 times 5, which is 45, 45 times 1/3, which would be 15. Okay, so now these are our two separate volumes that we're going to add together. So we're going to add those together and we're going to say the volume of the composite solid is 105 pi, and we're talking about meters cubed. And now we can approximate that by typing in 105 pi in our calculator. So times pi, and we're going to get an approximation of 329.87 meters cubed. And that would be our volume for that composite solid. And that's how you find the volume of a cone.